The next thing we're going to look at in section 11.1 is called an initial value problem. So this actually is kind of the bridge into the discussion of definite integrals, which will come up soon enough. I'm sure you're a little excited about that. Anyway, what we're looking at here is we're looking at a function that is the derivative. So we're looking at f prime of x being equal to this expression, and we're told that the value of the function f at 2 is 4. What we're trying to do in this situation is find actually what is f of x. So to do that, we're going to use integration. So here's the deal. F of x is going to be equal to the integral of f prime of x. Now remember, there's a whole family of these that exist, but you'll see what happens with the c value as we progress through this problem. All right, so what we're going to do is go through our basic rules of integration yet again. So that would be to add 1 to this 2, making it a 3, then dividing by that 3. And then this is really x to the first, so now it's x squared, because we just added 1 to 1, giving us 2. We're going to divide by 2 and put the plus c. So go ahead and let's go ahead and simplify this. That's going to be x cubed minus 3x squared plus c. But here's the deal. We know something more, just not this indefinite value. We know that the value of the function f at 2, when x is 2, gives us a result of 4. So here we go. I'm going to use substitution now. So f of 2 equals what? Well, f of 2 equals 4. So I'm letting x be equal to 2 now. So wherever I see an x, I'm going to make it a 2. And what this is going to allow us to do is solve for c. This is the first time we've been able to do that thus far. So what is this? 4, that's what? What is that, 12? So we get 4 equals what? Negative 4 plus c. So we add 4 to both sides here, guys, and then c is what? Therefore, c is 8, which means we're now able to define the function f as what? As x cubed minus 3, still can't draw 3, x squared plus what we just came up with. So this is our actual function f based on the derivative being equal to this and based on this given initial value of f of 2 equaling 4. The last example in section 11.1 is an application type problem. So if you read the example in your notes, notice you are given the marginal cost function. Our goal is to do what? We're trying to find the total monthly cost incurred in manufacturing X guitars per month. So our answer is going to be this. We're trying to find c of x, a cost function in terms of x. All right, so we're going to handle this one basically the same way as we just did the previous example, the initial value example. So what do we have given? Well, we know that c prime, or the marginal cost function, is equal to this. And furthermore, we know that the fixed cost, which means the cost without looking at selling anything, or c of 0, we haven't sold anything yet, the fixed cost is $4,000 a month. All right, so no matter how much you sell, it's still going to cost you $4,000 for whatever reason. That's your fixed cost. So c of 0 equals 4,000. All right, so what do we do? Well, the same thing we did in the previous example. So in other words, we're going to determine c of x based on looking at the integral of the derivative. So we're actually undoing the derivative, which is why we can refer to this as the antiderivative. So write this down. And now we follow, once again, our basic rules of integration. So what do they tell us? Well, this is x to the first understood. So we're going to add 1 to that, making it 1 plus 1 or 2. And then we're going to divide by 2. In our second term, we are starting off with 100. When we integrate that, we now have what? 100x. Please know that the antiderivative or integral of a constant is always equal to the constant times x. Okay, so now we know that c of x is equal to this plus c, and then we go through our motions just like we did in the previous example. So c of 0 is equal to 4,000, so I'm going to put 4,000 here. And then wherever I have an x, I'm going to replace it with a 0, which this is kind of a moot point here. But I'll show you where the numbers go, just in case they're more complicated in the future. So every x became a 0, and c of x became 4,000. Now all I got to do is solve for c. Well, this is a big challenge here. This is 0 plus 0, so that's what? 0. So therefore, c is equal to 4,000. Which implies that the function we're looking for, which is our cost function, c of x, is equal to what? Well, let's go ahead and reduce this. So this is what, 0.002 or 2 what? Thousandths. 2 thousandths divided by 2. That's going to be the same as 0.001. X squared stays the same. Plus 100x stays the same. Plus what we just came up with for c, which is 4 grand. And we are finished. Oops. We are finished with the notes from section 1 in chapter 11.